Now, with the concept of magnetic field around a current carrying straight conductor, we will try to figure out what will be the field around a circular loop if the current carrying conductor is converted into a circular loop. The same current carrying conductor is now turned and made a current carrying loop. So, see the clear picture of how will be the field, magnetic field around that circular loop. So, first we will find out intensity of the magnetic field, then what will be its shape, direction, and we will have a clear picture of magnetic field around that circular current carrying loop. So, about the intensity, it's pretty simple because it's the same current carrying conductor just turned and made a loop. The magnitude of the magnetic field will be directly proportional to the intensity of the current through it, as in the earlier case. Similarly, the intensity of the magnetic field will be inversely proportional to the distance from the conductor. The point far away from the conductor will have lesser magnitude compared to the field nearer to it. So that is about intensity. Now about the shape of the magnetic field in this. Here, as we know, in a current carrying conductor, the magnetic field is concentric circle around it. Similarly will be the case if we take any particular point in the loop. The shape of the field due to that particular point, let's say P, will be concentric circle around that particular point. And as we move away from that particular conductor, that particular point, the circles are becoming larger and larger. So now if we see the picture where we are taking 2 points on the circular loop and we try to see the picture of magnetic field around it, we will find the concentric circle around that particular point. And as we are moving towards the center, they are becoming larger and larger from both the direction, and we can say that the magnetic field is a straight line or parallel lines at the center of the loop, and this phenomena will take place at every point in the loop around it. So if we see how the iron fillings will behave in that scenario, see the video. So see, if we place iron fillings on a paper through which we see a current carrying conductor and current passes through. So you will see a straight conductor. The similar way you will see 2 concentric circles around both the points. And now about the direction of the magnetic field. So here you can see in this picture there is a current carrying conductor in which the current is going in the clockwise direction. Now we take 2 points. So in this case you can see at this point the current is going upward. According to the right hand thumb rule, we will get the magnetic field lines in the anti-clockwise direction, right? So the magnetic field lines near the center of the loop due to this point will be pointing this way. Now if we take another point and we try to figure out the direction of magnetic field here. So at this point we will find that the current is going downward. So according to our right hand thumb rule, we will find that the direction of magnetic field is clockwise. So at these 2 points we find that the direction of current is different, so also the direction of magnetic field is different. But when it comes to the center, we will see the direction of magnetic field due to both the points is same. So we can say that the section of the wire contributes to the magnetic field lines in the same direction within the loop. So these kind of concentric circles and these kind of parallel lines near the center of the loop will be contributed by every point in the loop. So the overall picture you will see that all the points are contributing their own magnetic field, which are all unidirectional and almost parallel at the center of the loop. So we can conclude that magnetic field due to a current carrying circular loop is inversely proportional to the distance from the wire, as well as it is directly proportional to the intensity of the current passing through it. Shape, you can see how it is looking like, and about the direction, we will use the right hand thumb rule and figure out. So that is the overall picture of a magnetic field due to a current carrying conductor, which is a circular loop here.